Hello, we're going to look a little bit about moving from logical design to physical design. We're going to look at SQL Server Management Studio and create some objects, database, and some tables in SQL Server Management Studio. So we've done the logical design. You may have something like this, which I call relational notation. This shows that there are 4 tables and the keys and the foreign keys here. In addition, what's not shown in this relational notation are the constraints on each field. For each relation, you should think about the constraints. Constraints could be as simple as data types, the primary keys, or what fields are required. Now, I want to give you a hint on required fields. If the minimum cardinality between a foreign key and a primary key is the 1, then you should know that that will be a required field for the foreign key. And what you're going to do is, let's suppose that everybody is supposed to have a department, and department is a foreign key. Then you should indicate not null, which this does say required, yes, and in the SQL you're going to write not null. If the minimum cardinality between a foreign key and a primary key is set to 0 or optional, then the required part will be null. You do not require that foreign key. So you're going to go from here, this is our employee table, to something like this, where you indicate the column names. You're thinking about the data types. Now this data type auto number would be an access data type, it looks like, and whether something's a key or not, and whether something's required, and any other constraints that you may add. Here's another example. This one, again, indicates similar data types, and we only have the 1 primary key field, and yet other fields are required. We've got payment type set to a default value of cash, so that's something you can do when you're designing the physical design. Other remarks include that the invoice number is going to be a surrogate key. We're going to start at 35,000. An increment every additional record will be 35,001, etc. We also have a constraint showing the format of the date. So constraints are based on the business rules, which you have gathered in the conceptual design phase of designing a database. So the next step in the physical design, you have the option then to go into SQL Server from the command line window, or to use SQL Server Management Studio. You have the option of having a whole script of SQL and running it all in batch, or keying in one at a time and run it and see how it works. Now, I believe when you're starting, the way to do it is the latter. Do one command, execute it, see how it works, then the next command. Let me just show you the command window. So I'm opening the command prompt, and BCP would be an SQL Server command, so you could use this command window. I know that you would find this more difficult to do, and maybe once you become an expert, you'll find yourself in it all the time. So the first command that we're going to look at is creating a database. At its simplest form is what we're going to do is you're going to use the SQL create command. And what are we creating? Well, we're creating a database, and then the name that you're going to give your database. We've talked about naming conventions. Make sure you don't have a space in the name of your database. So generally, the create command can create any object in the database. And the syntax in its simplest form is create, the type of object you're creating, and what you want to call it. And then these brackets mean additional features optional. Did you notice that each of these commands ends with a semicolon? SQL Server Management Studio will forgive you if you don't include the semicolon when you're running each statement one at a time. However, I believe you should just get in the habit of using semicolons at the end of each SQL command. One other thing you may notice is that it's generally a standard that the SQL keywords are capitalized. So you notice create, database are capitalized. However, if you don't, it still works. Okay, so let's create. a database. We'll call it HR. And then we're going to use the use command to have the user use the database. So I'm going to go into SQL Server Management Studio. So you would type in SQL Server Management. It should come up here. This is a server. You will need to connect to the server. What you should see here is the name of your local machine. So I have a Surface. I haven't renamed it. So my server name is Surface. In addition, as you installed, I don't know if you recalled, you had the option of indicating how you wanted to create the logins. So there was a Windows Authentication or a mixed mode authentication. I chose Windows Authentication and put myself down as an administrator. So here's my login to SQL Server. Just uses my Windows login to authenticate me. However, if you did choose SQL Server Authentication, change that there. Put your login and the password that you created here, and remember your password if you would like. So I'm going to connect, and here we are in SQL Server Management Studio. Very important, over to the left is our Object Explorer. So these are all the objects in the database. We're going to focus right here on the database objects. We'll do a little bit with the security objects. The rest of these objects are optional objects I installed with the full install that we will not be using in this class. Also, here is the name of the server itself. To create a database, you will click on the new query, and this opens up a query window in the middle, and these properties over to the left that you could set. So the query window, if you notice, that SQL Server has already assigned a name with an extension of .SQL. So simple queries are text files that you can save external to the database. These text files, I could create a big batch just like you could create a large HTML file, which is a text file. And then I can share these batches with other people, and then they can run them within their system and run similar queries that I have already written. Now, this is a fast way to actually have everybody on the same database, because I can create a big batch that creates the database and the tables and share it with you. Then we're all working in the same database together. Let's start with creating our database. So we'll type, we're creating a database, so we start with create database, and I'll call this database test. And you will notice, first of all, before I execute this, that I am in master. Okay, so master is one of the system databases that is all of us have it. It's automatically installed. And you can think of master as being metadata. It's a database about the databases. So I'm going to execute this. And down here I get a message. So if there was a typo somewhere, this would be red and it would give me a hint of what the error is. But this is a pretty simple command. This asterisk means it hasn't been saved yet. I don't know if I will save that. Okay. And I created the test. Now let me tell you, since I have this expanded, I don't see my test database. And this happens frequently. You have two options. You can collapse it and expand it again, or you can right mouse click and click on refresh, and there's my test database. Okay, so I can expand my test database, and these are all the objects that we will create. Not all of them, but we'll be creating a lot of these objects within our own database. Now you'll notice right now that I'm still in master. So if I start creating a table right now, that table will be created in master. Okay, so I'm going to create a new query, and I'm just going to write use test and execute that. Now you will notice up here I'm in test. So let's go ahead and talk about batch. I could have done that in a batch. So in a batch, I could have written create database test2, Go. And go is not an SQL command, but go says run that command before you run any other commands below it. And then I'll do the SQL command, use test2. So this is a very simple batch. SQL Server is giving me an error right now because the test2 object hasn't been created, but I'm aware of why we get the little red squigglies. But let you know that when you type in objects, if they're not there, SQL Server lets you know that you have a typo there. Okay, so we have a batch. I suppose I could type go. That's optional here. Notice I'm using the semicolons at the end of the SQL commands, and the go says execute what's above it. So we'll run that, and that command has successfully run. I will refresh, and you will now see I have a test2 database, and up here I'm in the test2 database. Okay, you don't have to use the use command in the Management Studio. You can go from database to database using the drop down. But be very aware when you're starting to create other objects that you're not sitting here in master database or model database creating tables. Make sure you're in the correct database. You will see that another way to create a database is to use the Object Explorer itself. That Object Explorer has a lot of context-sensitive menus. If you right mouse click on objects, it will bring a menu up related to what you're clicking on. So if you right mouse click on database, this context-sensitive menu allows you to create a new database without typing in the SQL command. However, for this class, I am very interested in you learning the SQL and not just mastering the GUI part of it. So pages 105 and 106 of the textbook shows you how to create a new database. Very simple. And there is a lot more information in this dialog box than the simple SQL command that I have given you. So we created a database with all of the defaults because we didn't reset any of the properties or any of the optional attributes we could have set. In fact, here I am at Microsoft's MSDN site that shows the syntax of the create database. And this is all we've done. If you notice, everything else in the syntax is optional. And these are all properties. You could have keyed these in the SQL window. However, it gets pretty complex. We're trying to keep it simple. Okay, so in Object Explorer, I'm going to go ahead and demonstrate creating a new database. I right mouse clicked on database, new database. Here comes that window, and there are several pages that you can select with different properties. So these properties correlate with those optional commands that you saw, such as collation, how you want it to be, what the sort order is what collation means, file groups. Let's go ahead and just look at general. Now this is good to know that when you create a database, got my 23rd test evidently, you will notice it's going to actually create two files. And you'll notice that you're setting the initial size of them. Test 23 is the database. This is the log file. And the purpose of the log file is if anything crashes, it's a way to recover all the data. So what normally happens is usually there's at least a nightly backup of your database somewhere. If all day long you've had your clerks doing their data entry, adding new records, or if it's a back-end database for a website, it's the users probably keying data into a web form and creating records for you. And during the day it crashes. You can go to your backup, restore from last night's backup, and the log file will help you generate anything you've lost since last night's backup. So here are just the default settings that you used when you did the create command. So if you don't want the default settings, you can come in here and modify it. Also look at where this file is being saved at. You do not have to save it in program files. So there's a data folder in program files that it's saved at. In fact, it's recommended that the log file be saved on a separate hard drive than the database file. I think that's a good thing to do. So I'm not going to actually add that. I just wanted to show you another way to create your database. Let's now get a broad overview of SQL statements themselves. So there's 3 types of general SQL. One's called DML, which stands for Data Manipulation Language. You're changing the actual data. This is done with modify, insert, or delete statements when you want to do those. Let me give you an example. Again, you've got someone on the web, let's say a site that's selling objects, selling items, and as your customer wants to buy something, they click on go ahead and buy it, it has to generate a new record. So in the code, the server-side code, there will be an insert command based on the data the user clicked on your website. So if you are working on websites, you are using data manipulation language a lot to modify, mainly to add new records. There's DDL, data definition language. So most of these are your create commands, such as create database. Likewise, there's something called alter. So if you want to change an object, you have an alter command. And there's a drop command. If you want to drop an object that you've created, you can use the drop command. So things that you see over there in the Object Explorer are created and modified using DDL. Finally, there's DQL, data query language. This is when people talk about SQL, this is normally what is thought of, and that's your select statements, where you're getting the data that's being requested for a report. So you may be thinking, if I'm able to do this through Windows dialog boxes, why do I need SQL? Well, if you're going to do any server-side programming with a back-end database, you're going to be using SQL. I've just thrown out some examples. Even COBOL will embed SQL with the exec SQL command, and here's the select statement. That is SQL. Here's PHP. PHP is often combined with a database called MySQL. And here is a command to connect to the database. And here is the select statement. It's going to execute. And here we are, C#. You may be familiar with C#. Here's a command to open a database. And here is another select command. Now these are all very simple SQL statements, but to show you that you will need to be working with your input parameters to create SQL statements in server-side coding. In the next video, we'll look at how to create tables and how to use all those constraints we were talking about earlier in tables.